Okay, so some things happened yesterday that I feel like maybe was a little tough to catch from home. And that's okay. You don't have to know how to recreate that sine of theta over theta equals 1 proof for me. I just need you to know it. I need you to know that that is true. That whole squeeze theorem thing is just a fancy, cool way to do stuff. And we just haven't seen that before. So I wanted to show that proof to you so that you've seen it, you've heard of it, even if you haven't mastered it. I'm never going to ask you to recreate that proof yourself, but I do want you to know these proofs. But way, 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 way more importantly for me, although I spent way less time on it, just because it doesn't take as much time, is the proof that's on the right for that last one, the 1 minus cosine theta over theta. And the thing that I said yesterday that I reiterated over and over and over again that I cannot say enough is how important it is to recognize how that proof there on the right was done. Very simple algebraic stuff. Oh, multiply by the conjugate. Use a Pythagorean identity, no big deal. The action happens from line 2 here in blue down to line 3. Where we do something that we've never done before. You know, when it was just, factor and divide, sweet. Rationalize and divide, great. Just plug it in, cool. Like limits up to this point are purely algebraic in very kind of obvious ways. Or at least they get more obvious as we do them. But this second proof to figure out this 1 minus cosine of theta over theta 1, because again, 0 over 0, there's a hole there. So I got to be able to find it somehow. This one was a little different. And I had to start with the sine of theta over theta proof first, because then I use it. And the thing that we are going to work on today, tomorrow, if you need this weekend, is trying to do limits like this that are a lot more analytical than they are necessarily like just purely algebraic. Obviously, we're doing just algebraic manipulations, but you have to know what to look for. And that was the thing about this proof, is that when I go from this line right here, this step, with sine squared of theta over theta, 1 plus cosine of theta, this is a little sloppy from the second period, but the idea was to go and search for one of these two, or really any of these three. This is just what I multiply stuff out, right? Oh, I have sine of theta over theta, but there's multiple numbers being multiplied in. Fine, just multiply the numbers and don't worry about anything else because that limit is just 1. And so what I want you to realize is that the end of chapter 1 here with limits is trying to get you to look for certain limits and isolate them. That if I can get this by itself, I can take that limit, it's going to be 1. If I can get this by itself and I can take the limit, it's going to be 0. And so what I do from this line in blue to this line in red is I take one fraction and purposefully split it into 2 in a way that isolates one of those limits. Okay, and that's what you have to start looking for. How can I find sine of theta over theta? How can I find 1 minus cosine of theta over theta if I can't just plug it in? Or if I can't just factor and divide? Or I can't just rationalize? If we get stuck. This is one last blessing, one last idea. And this is what I said over and over again. I'm going to say it again. The limit of a product, a couple things being multiplied together, is the product of separate limits. That if you have some stuff being multiplied together and you want to take the limit of all of it, take the limit of each piece separately. Because then that limit right there is just 1. How do I know that? Because it's been proven and now I can use it. And then with this one, I can just do it. Like I can just direct substitution, right? Oh, plug in 0. Okay, 0, sine of 0, 0. Over 1 plus cosine of 0. Okay, so 1 plus 1. 0 over 1. So 0 over 2, 0. And what I want us to try to do today, as much as we can, is start getting used to that idea that, number one, if you can just plug it in, just do it, right? If you can factor and divide away the problem, just do it, right? Make your life a whole lot easier. But if you can find and isolate those sine of theta over theta, or the 1 minus cosine of theta over theta limits, this gets a whole lot easier. And so I want to do a couple with you that highlight that process. We did number 5 together, but that was yesterday, and obviously you guys at home were here, but everybody else who was at home might not have caught up as much. But so the hard part about this for a lot of people, like beginning calculus students, is like, okay, tell me what to do first. Like, what is step 1? And the answer to that question is, I don't know from one problem to the next. It might be, hey, let's factor. Or it might be, hey, let's split apart the fraction. Or hey, let's divide stuff away. Or hey, let's use an identity. Right? We don't know what's going to happen, so we just have to look and see if something sticks out. We have to, unfortunately, be okay with starting these problems, failing, and starting them again. And that's okay, which is why I don't mind if we push the due date for these 5 pages to like Sunday. We need some more time besides today and tomorrow, especially with us having 39 minutes of class instead of 50. We might need that extra, handful of minutes to finish things up. So let's turn to page 53. Let's look at number 6 first. We did number 5. The reason I'm not doing 1, 2, 3, or 4 is because those are more straightforward. And when we get 6 and 7 done, I will just put up the solution. You can just check them out once as you try them on your own. But lots of downtime to get practice and ask questions. But I want to at least try some of these on your own, because this actually highlights 2 of the ideas that work really well. Do you notice anything about the setup with number 6 that maybe we could try? Yeah. Cool. Now, you're already starting by, all right, let's mess around with it. Let's start rewriting it to see if it does something useful for us. And why that's a good idea is because we can't just plug in 0, right? And that's always, remember, that's our first thought, is can I just plug in the number and see what I get? And if the answer to that is yes, then we're just going to do it. But if the answer to that is no, it's time to start factoring, looking for identities, breaking fractions apart, doing something. I love that idea of trying to pull out that common factor of 2 on top. Again, hold on to the limit notation as long as you need to, basically until almost the very end. And folks at home, chime in, of course, if you see anything. But anybody recognize? Okay. So 1 minus cosine squared, recognized as a Pythagorean identity. What is that? That is sine squared. Good. 2 sine squared. And it is really nice to get to this point, because I used to have 2 terms up top, and now there's just 1. But that's all like the simplifying we can do. There's nothing to divide away. Now there's nothing to factor out. We did make things a little bit simpler, but we're still kind of stuck. But when I see that single denominator of theta, like right away, I say, oh, you want theta to go to 0 and the denominator is just theta? I need to start looking for things like this. If I can find versions of these, by maybe doing kind of what we did here, right? Breaking one fraction into 2. And if it's connected by multiplication, they will just break it into 2 fractions being multiplied together. If things are connected by addition or subtraction, then we'll just break them into fractions being added and subtracted. The thing that we just have to watch out for is when we do that, that's a 0, not a theta. When we start breaking one fraction into 2, there's a big difference between when we break it into a product and we break it into a sum, right? When it's a product, I have to remember that I'm going to multiply all the tops back together, multiply all the bottoms back together, and it's got to give me the line before, right? When we break it into addition or subtraction, I have to have common denominators, and I just keep them the same. So, do you see a way to isolate either like a 1 minus cosine of theta or a sine of theta over theta based on some factors that show up?
Sine of theta over theta times sine of theta over theta.
Can I put the nice one first? Yeah. The sine of theta over theta, and then what's left? And look, like sine of theta times 2 sine of theta, sweet, 2 sine squared theta. But if I use the entire denominator for this one, if that was theta on the bottom of both, then it would have been theta squared that we would have come to. And so it's hard at first to know to look for that until you do 5 pages of practice looking for those kind of things. And that's what I want to try to get you to, is a point where you know what to look for and how to look for it. And here's the best part about this. I can't do anything yet, but I can use a property of limits. The limit of a product is the product of 2 separate limits, both going to the same spot, one with the first fraction and one with the second, which is just 2 something. We're a little big today. I'm going to have to come right down here and write the answer. And so every step was taken logically and clearly too, right? And that's kind of what we want to do, is we don't want to jump too fast. I don't want to jump from that blue line right there with the 2 fractions right to the answer. We want to show that step in between where you've got, okay, 2 separate limits, and we just see what happens, right? That's our theta. And so what is that first limit? The limit, as theta approaches 0, of sine of theta over theta. Got to know it. Like, that's boom, 1 right away. Times. Well, it's just the limit of 2 sine of theta. Plug in 0, see what you get, right? Now the problem has been, like, pulled out, right? Dividing by the theta and dividing by 0 was taken care of right here. Now we can just drop in, and look, I got rid of my limit notation. I know I'm down a little low, hopefully you guys can see that. I got rid of the limit notation because I took the limit of the first one. It is 1. I'm taking the limit of the second piece, which is just 2 sine of theta. So 1 times 2 times 0. Sine of 0 is 0, so my answer is 0. Calculus A, a lot of work for a simple answer. That is calculus A. Calculus B, a lot of work for a complicated answer. Okay, and the more you practice, the easier this stuff gets. Knowing what to look for and trying to figure out ways to isolate it, that's kind of what we're going. So this one was a product, clearly, because things were just being multiplied. It was 2 times sine times sine. And I just kind of pulled out what I wanted, and it doesn't matter what order you do them in. You just want to make sure that you have one of, oh, press the wrong one. Searching. It's going to go back to what I said. Looking for one of these 3 things here on the left, okay? The 2 at the bottom are the most important ones. The one on top is just kind of an adjustment of the one in red, right? Oh, I have things being multiplied. I'll just multiply them all together. I just worry about the constants because everything else just gets me to 1, right? A times sine of B theta. Oh, A and B, multiply them together. Oh, D theta. Okay, D. I don't have to worry about any other piece. Okay, piece on the right was just the proof of that last one. Okay, let's do 7. But when you look at 7 and you look up top, are things being multiplied together? No, things are being added and subtracted. And so when I decide to go hunting for one of those or both of those trig functions, those trig limits, I'm not going to break it into 2 fractions being multiplied together. Things aren't being multiplied. Things are being added and subtracted So that's kind of my goal, is to see if I can break this up right here, parentheses, because I'm going to break it into some stuff being added and subtracted. You want to just start looking for one or both of those limits. Sine of theta over theta, or with some constants. Or 1 minus cosine of theta over theta. And we'll just see what happens. Do you see either of those limits kind of buried in there? What do you see, Sam? There it is, right? There's one of those limits. 1 minus cosine of theta over theta. And so if I purposely break the fraction apart into 2 different fractions, I need a common denominator to do it. So I know if I'm going to choose that as the denominator for the first one, I better choose that as the denominator for the second one so I can add them back together. Yeah, kind of like, all right, I'm going to take a step, but make sure it's still the same, means the same thing as the step right above it. Again, why did I choose plus? Well, because nothing's being multiplied. I can't write it as a product if things aren't factored yet, right? This is just a sum, so I'm going to break it apart. But I didn't do like 1 over theta minus cosine over theta. 1 over theta is not a limit I know. Cosine of theta over theta is not a limit I know, but 1 minus cosine theta is. And so what's the top of that second fraction then if I've used the 1 and the minus cosine theta? Sine of 2 theta. Good. The limit of a product is the product of limits. The limit of a sum is the sum of 2 limits. Properties of limits allow us to do that, which is so nice. Just like, properties of exponents, properties of numbers, properties of everything. Limits are definitely part of that. 1 minus cosine of theta over theta for the first one, and then sine of 2 theta over theta for the second. Like, do you get it? Does it make sense how I'm able to do that? Okay. What's that first limit? 0. Now, if that second limit was just sine of theta over theta, it would just be 1, right? But it's not sine of theta, it's sine of 2 theta. Okay. 2 instead of 1. It's like, 2 times 1 is really what's happening. Which, of course, is. It's almost like you're factoring out the constants from the limit. Like this 2, we're able to like pull that out in front and say, oh, 2 times the limit of sine of theta over theta. Oh, that's 1. Okay, cool. And that's the idea. That's the plan. And as much fun as it is watching me do it, it's time for you to try. Okay. And we're going to take the rest of today, the last 20 minutes or so that we have, and then the 50 minutes tomorrow to try to do as much as we can, as well as you can, knowing that you are going to run into roadblocks pretty often, and you should ask for help. And so this can be a time where you talk to each other. This can be a time where you talk to me. This can be whatever works for you. Because I've already done all the answers. And I'm happy to share them with you as we go. I think you should turn back to start at page 52 and go back to 1, 2, 3, and 4 and just feel okay with some of these simpler ones. 1, oh, I can just plug it in. Cool. I'll just plug in the number, see what I get. 2, 3, and 4 kind of work through that whole sine of theta over theta with numbers attached. And you can see that I just worry about the constants. And then 5, 6, and 7 are done. And then when you're ready, like again, try these yourself. Make sure you can do them. There are more examples like these in the coming pages. So as long as you believe in it, it should go. And I just want to let you try it. And then you get stuck and you say, hey, Rosie, can you turn to number 8? Can we talk about it? Or, hey, can you explain 3? Or, I didn't get 5 yesterday. Can we do that again? I want to help you, and that's in turn going to help everyone. Here's that ball. And lid on Tuesday, we'll do some regular. So I'll leave this up for another minute or two, and then I'll scroll to 8 and 9 so you can see those when you're ready.
Sine of 4 to 4 is that one?
For number 2?
Yeah, like how do you get rid of like sine?
So what's happening, it's not algebraically correct, which is why I'm not actually writing it, but the constants can be factored out. As a times. So it's kind of like 4 times that limit.
Yeah, that makes sense.
So, but what I've done is I said, you know what, I'm just going to make my life easier, and I'm just going to worry about the constants. 4 in front of the theta on top, and the 1 in front of the theta. And that's okay. I don't mind you writing it like that. Like when you look down at 4, oh, I just pull up the 2, pull up the 5, multiply them together, pull up the 3 on the bottom, do it again. Yeah, we can work quickly through the simpler ones. So you're starting to add a lot of different skills and tools to your calculus toolbox. Factoring, rationalizing, multiplying by conjugates. And now this whole like breaking fractions apart to try to isolate some of those trickier limits that just can't be proven algebraically, except with like the squeeze theorem and then, yeah, right. Number 8, sure. So I would love to divide away the thetas and the cosecant thetas right from the beginning, but I can't because they're not being multiplied on top. They're being added with the 1. So I can only divide away things that are being multiplied. And right now, the theta cosecant of theta is not being multiplied by 1, it's being added to 1. And so I needed to first break the fractions apart. The theta cosecant of theta, and then the 1, separate numerators for 2 fractions, both over the same denominator. Kind of like what we did in 7. I isolated something I knew I could do something with. But seeing that was huge, right? Noticing, oh, I have a theta on top and bottom, I have a cosecant of theta top and bottom. Let me see if I can get those isolated so I can divide them away. Because that's what I do here, right? I say, ooh, look at that. See ya. Now that's just 1. Great, great idea. Then we have to use a little bit of knowledge and trickery to recognize that cosecant and sine are reciprocals of each other. So when I write the other one, I move it from top to bottom, or in this case, from bottom. Right? The cosecant on the bottom becomes sine on top. Oh, you're good. Limit of a sum is the sum of individual limits. Limit of a constant is just always going to be that constant. The limit of 1 is just 1. And then sine of theta over there. Also.
Hey, Rosie.
Yeah.
Can you scroll back up to 2? I just wanted to check my process real fast. I couldn't see it just kind of like cut off. Thank you.
So I just pulled out the constants because I noticed the sine of theta over theta and theta going to 0. And so that's where that 1 comes from. It's just 1 theta on the bottom. And that's probably even more work than I really needed to show, which is crazy that I don't need to show a whole lot of work for that, but it's true. We're good. I'm going to put grades in the grade book for our last quiz. Finally got everybody, I think that needs to take it, so that's good. So I will drop those in either during lunch or during 6th and 7th. I'm actually giving tests in my algebra 2, so I'll have some time to get stuff in the grade book. If you want to talk about how you did, if you want to look back at that quiz, sometime this week or early next week, we should do that. Because the way that things seem to be lining up, is we will take today, tomorrow, and if you need it, the weekend, to finish up these handful of pages, just to get some practice in with these ideas. Hopefully by the end, you're like, okay, I think I get it. I got it now. Sweet. Monday, maybe / Tuesday. We'll see how long it takes. Probably just take Monday. To put like a bow on this chapter, right? Limits and continuity. Let's talk about those together and see what we can figure out. And then certainly at least 1 day of review, where I will come up with some practice for you that goes back to first half of chapter 1 stuff in addition to this kind of stuff. Now, what I didn't want to do was say, okay, like class Monday, review Tuesday, maybe Wednesday, and then give a test on Thursday, half of you in person and then half of you at home. I didn't think that was equitable. So, but I also didn't want to do like, hey, cohort A, you have to take your test on Wednesday, and then cohort B, you have to take your test on Thursday, and not get quite as much review in. So I think what I've decided is, although I would like to give you a test in person, I just don't think the timing has worked out to do that. So I think our test is going to happen Friday at home at your convenience. Okay, so I will send it out first thing Friday morning, just like I did with the last one. Google form, if you can just answer it right there, great. If you have to show some work, great. You just do that and put it up on Canvas. And you can have as much time as you need, and you can do it whenever you want to on Friday, when your brain is ready for some calculus. Does that sound good? So a week from tomorrow, chapter 1 test. Coolio. And that'll give us lots of time to review, lots of time to practice. And then your Friday, you can just do it whenever you're ready. And then we can all start together Monday with the start of chapter 2. And that'll get us to March, which is perfect. So we spent 1 month on chapter 1. That's pretty good. That's kind of what I was, and it's a short month. We spent, let's see, we spent 19 days on it. That's pretty good. Okay. Including 3 asynchronous Fridays. Gotta be 4 with the test itself. So I think we are doing pretty well. I mean, correct me if I'm wrong. Do you get it so far? Awesome. Good, good. And if you don't, you'll have lots of time to bridge some gaps. Yeah. Yeah, for sure. Okay, so 9 was similar to 6 in the fact that once we factored, we were able to spot a couple of those limits. And so what I did with 9, because I didn't know where to really start, but I noticed that there was a common factor, sine of x on top. So I factored that out to see what it could do, to see if something showed up that I started to recognize. And what I saw is that, okay, well, I just factored, so I have a product. That thing's been multiplied together. So is there a way for me to break this one fraction into 2 or more with multiplication that isolates the kind of limits I know I'm supposed to look for? And with a denominator of x squared, I could pick 1x for the first one and 1x for the second one because of that. And that's what I'm looking for. And I know that sometimes like they give us theta, sometimes they give us x, and so I think they're trying to get us used to seeing both. But once I factor out that sign, I could take the sine of x, put it over one of the x's from the bottom, and then the 1 minus cosine of x over the other x, because it was x squared, so I needed one and the other. And there they are, right? The limit of a product, there's my two limits, and those are the two limits that we can use. Sine of x over x and 1 minus cosine of x over x. So right away, 1 times 0. Does that make sense?
Yeah. So for when you do the two limits multiplied by each other,
Yeah.
One times cosine. Oh, okay, never mind.
Right? That limit is 1.
Yeah.
That limit is 0. Those are the two limits that we know. We can use them right away. Like once they're proven, it's like they become common knowledge to us. And it's like, and this is a very unique one. Like usually we're just looking for one or the other. This one has both. It's really the only way I could do that is to have this exact kind of setup. So, right, 8 and 9 are really good examples of the two kinds of things that can happen when we try to break fractions apart. Break it into a sum on the left, see what happens. Break it into a product on the right, see what happens. Trying to isolate it.
Mr. Rosengren,
Yeah.
for 8, how did you go from 1 over like theta cosecant theta to sine of theta over theta?
Very good question. I was waiting for somebody to ask that pretty specifically. Okay, so do you agree that 1 over cosecant of theta is the same thing as sine of theta? They're reciprocals, right? So it works in both directions. And if I were to multiply by 1 over theta on the left and 1 over theta on the right, is that still true? All right, multiply by the same thing left and right, so I'm good. So these two are the same. Now, how did I do that without having to show all those steps? Well, here's what I recognized, right? This is what I had. And what I saw was cosecant. And I know that that's the reciprocal of sine. And so instead of going through this whole process of dealing with complex fractions, and then writing it as a complex fraction, just to move this to the top to get me to there, if you have a trig function and you want its reciprocal, it just changes its location within the fraction from the bottom to the top or from the top to the bottom. But this is how that happened in my mind as I did that. But like, I took this class 18 years ago. 18 years ago, I took calculus for the first time. So I've had your lifetime of experience doing calculus. So I recognize that kind of early on, trying to look for sine and cosine rather than secant and cosecant. And so what I did is I said, oh, I have cosecant on the bottom of the fraction. Let me write it as sine and put it on top. Does that make sense?
Yes. So would it be fair to say that if there's ever, like, for example, secant of theta equals 1 over cosine of theta, if it was theta secant theta, it would just equal cosine of theta over theta?
So theta secant theta would be theta over cosine of theta, right? The secant becomes cosine and moves to the other part of the fraction. Is that what you mean? Like theta over secant of theta is theta cosine theta. By taking the reciprocal trig function instead, it changes its location within the fraction from the top to the bottom or from the bottom to the top. Does that make sense?
Yes, thank you.
Cool, you're welcome. And all I was really doing there was just trying to find one of those limits. I was just looking for it. And so if I know what I'm looking for, sometimes it's easier to find.
I kind of get help and then I argue.
Right?
You're wrong.
That's okay. That's calculus. We got to talk it out. Which one were you looking at? Number one. I don't know if it's helpful to like see all the answers or just talk through them together. I don't know what's better.
That's how I started.
But yeah, like
Definitely not.
recognizing that I have two different trig functions bothers me. So I tried to just get it down to one. Now, I'm glad you brought this one up because with our last couple minutes, this is super important. Look at what theta we're trying to get close to. We're trying to get close to 0. As theta approaches what? What does it say in the limit? All of these special limits are all 0. And it only works for 0. And so when you get to something like number 1 on that second problem set, right, page 50 something, 54 maybe, what we notice is that theta is not going to 0. And the moment that theta is not going to 0, the idea of looking for these special limits goes right out the window. I am not looking for sine of theta over theta anymore. I am not looking for cosine of theta or 1 minus. I'm not necessarily going to go looking for those. What I am going to try to do is make things as simple as I can, however I can. And so what I noticed was the cosine squared and a sine squared, two different trig functions. It's going to be really hard to simplify those. Let's get it down to 1. Diagram identity is a great way to do it. Great part about some of those diagram identities, they will end up as difference of squares. Factor, divide. I'm going to divide away the problem. I feel really good about just taking that limit using direct substitution. And I think that's why they started this problem set with one that wasn't going to 0. Like, that's a really special case. And I know we're going to spend like all of this time looking for those special cases. But they are really unique and special. So we don't want to lose sight of all the things we already know how to do. I know identities. I know how to use them. I can factor. I'm pretty good at that. I can divide stuff away. I can rationalize. I can multiply by conjugates. So we have all of those skills, and it's just like, okay, which tool am I supposed to take out? Yeah.
I don't know if there's an alert or not. I wasn't paying attention.
Okay.
How did we do the piecewise one?
So piecewise, we didn't necessarily spend explicit class time on it, but it has come up in some of the practice that we've done. We were just short on time at the time. And so I figured I would just kind of keep bringing it up as it happened. The idea with piecewise functions, if you're taking the limit as x approaches wherever the break actually happens, you just take the limit from the left and the limit from the right and compare them. So when I take the limit from the left, I plug it into the top one. When I take the limit from the right, I plug it into the bottom one. I see what numbers I get. If they're the same, then the limit exists, and it is at that number. Okay. If this number and this number were different, then they're not approaching the same spot from both sides. Yeah. There you go, 1201. I will see you all in front of me. I will see you on Tuesday, next time in person. But of course, I'll see you virtually tomorrow, even though it's Friday. Cohort A is going to come in, so you guys will join us as well. But we're just going to keep going. Just going to practice. Try this stuff out. Cohort A, I will see you all in person back to hopefully our normally scheduled time mañana. Any questions? Let me know. Stick around if you have anything. Otherwise,